Do you ever stop to think about the future? Do you wonder how you'll reduce your energy bills? Do you think about how you'll reduce your carbon dioxide emissions? Do you think about climate change and its effects on future generations? With ever-increasing demands for energy and escalating costs to match, the need for sustainable, clean and efficient energy sources is essential, not only to ensure the future of the planet, but also to manage future energy requirements. One such energy source is cogeneration, which creates both electricity and heat in a single process. As this technology is located at the point of use, it is an extremely efficient, environmentally friendly and cost-effective way of supplying energy for a wide range of users. ENER-G is the market leader in the provision of cogeneration systems, with experience dating back to 1984. We have installed a wide range of systems, from 4 kilowatts up to 10 megawatts worldwide. Our unique combination of experience, in-house technology and services means we are a single source for the design, supply and operation of cogeneration systems. ENER-G is also able to offer flexible project funding options that often mean no initial capital outlay and immediate cost savings.
From its manufacturing base here in Manchester, the ENER-G Group provide CHP product for use across Europe in a wide range of applications, from leisure centres to hotels, hospitals and industrial sites. The manufacturing business exports CHP into a number of countries across Europe, including Holland, Italy, Spain, Poland and Hungary, and through its cogen partners into Ireland and Canada. In the UK, we operate and maintain some 500 CHP systems in the field. Many of these units have been supplied to our customers under our discount energy purchase scheme. Under this arrangement, we sell the electricity generated by the equipment, and there is no capital outlay by the customer.
Conventional energy generation, where electricity and heat are taken from different sources, results in an efficiency of around 50%, due mainly to transmission losses. By utilising the heat created during the production of electricity, the efficiency of a cogeneration plant can reach 80% or more. Cogeneration therefore offers energy savings of up to 30% when compared to the supply of electricity and heat from conventional power stations and boilers. But it doesn't stop there. The environmental benefits of cogeneration are significant. Lower CO2 emissions help towards carbon reduction commitment, and the system can minimise the impact of carbon taxes.
As a general rule, a 200 kilowatt CHP would save our customer about £70,000 per annum in energy cost savings and 400 tonnes of carbon dioxide emissions, with a 3-year payback on the investment.
The engine generator and heat recovery system are contained within a ventilated acoustic housing. Natural gas, biogas or liquid biofuel is mixed with combustion air, which then enters the engine and is ignited by a spark from the ignition system. This combustion produces power to generate high-value electricity in the generator. The electricity is metered as it is fed from the CHP, passing into the client's electrical network or the local electricity grid. Heat is recovered by passing water around the engine, also ensuring the engine is cooled. This water then flows through an exhaust gas heat exchanger where more heat is recovered. The heat is metered as it is transferred to the customer for heating and hot water purposes through a plate heat exchanger. Capturing this energy brings the total efficiency of the system to more than 90%. As a result of burning clean gaseous fuels, the exhaust gas is inherently low in pollutants, but these can be reduced still further with a catalyst. The CHP contains a patented G-control system which monitors, protects and controls the equipment to optimise its operation. Remote access to G-control means that the equipment can be remotely monitored and optimised. Should a fault develop on the equipment, engineers are notified immediately and suitable corrective action can be taken. Our cogeneration systems are available in a wide range of sizes to suit all requirements, from 4 kilowatt units right up to large 10 megawatt systems. These units can be powered by natural gas, biogas, liquid biofuel or propane. ENER-G has a range of standard packaged CHP units that contain all engine generator, heat recovery and controls within a low noise enclosure. Where customers have a specific requirement, ENER-G has the capability to design bespoke solutions. Heat can be provided in the form of hot water, steam, or converted into chilled water for cooling purposes using trigeneration. Projects often include complementary technologies from within the ENER-G group, such as heat pumps, building energy management systems, and energy-efficient lighting. We are able to offer a comprehensive range of turnkey energy solutions for large industrial, commercial and public sector applications. In these circumstances, we may include the provision of a dedicated energy centre, together with all necessary infrastructure enhancements needed to fully optimise the energy requirements of a site. These projects can be funded by ENER-G, giving customers the freedom to deploy capital on core activities.
This is the Holywell Park area of Loughborough University, and we've installed a 1 megawatt CHP unit in a gas-fired reciprocating engine, and what that does is provide 1 megawatt of electricity into the campus and also 1.2 megawatts of heat that we can use around the site for both heating in the winter and absorption cooling in the summer. So it provides a very good solution for heating and cooling of the building in quite an effective manner. It's performed very well. Since it was commissioned in February 2009, we've had very good reliability, over 95% availability, and that's resulted in some very good financial and carbon savings for the university. On the first year operation, we've got about £150,000 worth of financial savings and also 1,800 tonnes of CO2, which is really key in the university's aim to reduce its carbon emissions and environmental impacts.
We started the Csepa wastewater plant in Budapest in 2007. ENER-G made the design work and also the installation work. We installed 3 cogeneration units. Each one is 1.4 megawatt, and we also installed 3 boilers. The power is 2.5 megawatt in each. We use the biogas on the engines. Normally the 2 engines run with biogas. If we have more biogas, we can also burn on the boilers. Regularly the boilers run with natural gas. It depends the power, what is the heat demand inside. On winter in Hungary there are minus 15 degrees, so we need the natural gas also to produce enough heat to the site. Normally we use the electricity at the site, it's 3 megawatt. The total demand from the site is about 6 megawatt. So the engines could be produced the half of the electricity demand. It's a 21st century technology, and it's a huge benefits for the town, for Budapest. Before the Csepa wastewater treatment plant, only the 50% of the total wastewater was cleaned in Budapest. Now this number is 95%. So it's a very green technology, and with also the cogeneration power, it's very efficient and very environment friendly.
So here at the Village Whiston we've got a 4,000 member health and fitness club, bars, restaurants, conference centre and a 63-bedroom hotel. We use a lot of power, especially in the leisure club part of the business. We wanted to buy cheap gas and turn that into electricity and save some money. We've been considering CHP for some time now, and Liverpool just seemed to fit all the criteria that the company wanted to use to test the system out. So we were chosen to be the first one for that reason. The fish has gone according to plan. It looks as though we're going to achieve the savings that we set out to do in the first place. which are in the kind of region of about 10% of our total energy costs, so we'd be really pleased with that. If we're successful here, then we've got another 23 hotel and leisure clubs to use, so we just roll it out straight away. There's no reason not to. It's performed flawlessly, to be honest. It's been a very simple transition from one to the other. In fact, we've not really noticed that it's been happening. The main benefits of the CHP system for us is that we look to save around about 10% of our total energy costs for the hotel. There's then a climate change levy for the hotel of around about £7,000 as a further saving, and then there's a carbon reduction saving that we'd look to make in the future of between about £3,000 and £4,000 per annum. It's a considerable saving on a business's energy cost like ours.
The computer department at Delft University in Holland wanted the security of a backup power supply in case the main supply should fail. ENER-G installed 2 standby generator sets with an electric output power of 800 kilowatts each. If the main supply should fail, the power immediately switches over to a battery backup whilst the engines start up. Once at speed, the supply will switch to the generator feed. Here at this cucumber greenhouse in Kampen, North Holland, one CHP system supplies all the electrical power required at the site with an output of 1,960 kilowatts. This unit not only supplies electrical power and hot water, but also has the added bonus of purified exhaust gases being used to cultivate the growth of the cucumbers. At ENER-G, we combine our unique experience with in-house technology and services to provide a wide range of cogeneration solutions. These solutions provide an environmentally friendly and cost-effective way of ensuring you meet your future energy requirements.